If your top 10 results are basically the same document 10 times, you need diversification. MMR is the classic fix, simple, controllable, and effective. Let's implement it and see the difference. You probably notice search results that repeat the same answer in slightly different words. That frustrates users and wastes screen space. After this video, you will be able to detect near duplicates and produce a top K list that stays relevant while offering varied perspectives. I'm Professor Pi, teaching search and IR from basics to advanced with simple, concepts-first Python that helps you solve bigger, real-world problems. MMR stands for Maximal Marginal Relevance. It is a simple re-ranking trick that balances relevance and novelty. Practically, it sits after your initial scoring step. You first score documents by relevance to a query. Then MMR picks items one by one to minimize redundancy while keeping relevance high. People use it for FAQ search, recommendation lists, and any ranked experience where variety matters. Put another way, success means fewer repeated answers in the top results and more coverage of different facets of the query. That is often visible with only small changes to ranking code and little extra cost. We will use a tiny toy corpus of 4-dimensional vectors so you can see the mechanics clearly. Now we will compute a baseline ranking for the query. This snippet ranks toy documents by cosine similarity to a query. The array X holds simple 4D vectors for docs IDs, and Q is the query vector emphasizing pip and a little conda. We compute R as cosine scores by normalizing by document norms and the query norm. Then we pair IDs with rounded scores and sort by score descending, with a stable ID tiebreaker, so ordering is deterministic. The output shows the top 3 most relevant items, which happen to be near duplicates in intent. Seeing duplicates in the top results highlights the redundancy problem we will fix next. Next, we will inspect how similar those top items are to each other. This snippet measures redundancy among the current top results. It maps the top IDs back to row indices, then normalizes those vectors in Y to unit length, so dot products become cosine similarities. The matrix C is the pairwise similarity across the top set. We zero the diagonal to focus on cross-item overlap. We find the most similar pair using argmax and return their IDs with a rounded similarity. This shows which top results are overlapping the most. A very high pair score explains why the list feels like duplicates to users. Now we apply MMR to build a diversified top K. This snippet applies MMR to pick a diversified top K. We first build S, a full cosine similarity matrix from normalized document vectors, so we can penalize near duplicates. The list pool holds all candidate indices, and cell starts with the most relevant item by R. Each iteration adds the item that maximizes 0.6 times relevance minus 0.4 times its max similarity to the already selected set. This balances keeping relevance while avoiding redundancy. The printed IDs show how MMR injects variety without drifting too far from the query. Next, we will expose the trade-off parameter so you can tune behavior. This snippet exposes lambda to tune MMR's relevance diversity trade-off. We keep the same pool and similarity matrix S, but now compute the objective as lambda times relevance minus 1 minus lambda times max similarity to the selected set. Lower lambda increases the diversity penalty and favors novel items, while higher lambda trusts relevance more and risks duplicates. Reducing lambda to 0.3 here aggressively suppresses similar items, which can surface more varied but possibly less relevant results. The printed list shows stronger diversification from the query's core intent. Now we will combine a relevance prefilter with MMR for efficiency. This snippet builds a small baseline, prefilter by relevance, and then run MMR. We first pick the top M candidates by R to shrink compute while keeping strong contenders. From that pool, MMR adds items that balance relevance against similarity using the 0.6 and 0.4 weights. The result pairs IDs with their original cosine relevance, making it easy to inspect both diversity and quality. Increasing M improves coverage but costs more compute. Decreasing it risks missing diverse options. The printed tuples are a compact, usable, diversified top K. In a real project, you would replace the toy vectors with real embeddings and use an approximate nearest neighbor index for large corpora. The flow stays the same: score, prefilter, compute local similarities, then greedy MMR selection. Prefiltering keeps the inner product matrix small and practical for production. Recap: MMR is a reranker that trades off relevance and novelty. Use it when top results are repetitive and you want facet coverage without large model changes. One caveat: too aggressive diversity can drop useful relevance if lambda is set too low. Next step: tune the lambda parameter on your validation set and measure the accuracy versus diversity trade-off. If short, practical IR helps, subscribe and watch the IR videos.